Hello, welcome to this CoolLED tutorial video for HCImage from Hamamatsu. In this video we're going to show you how to set up and integrate a pE-800 into HCImage. Firstly, connect the pE-800 to the computer and switch on the system. If you're running Windows 10, no CoolLED drivers are needed to be downloaded for integration. This can be checked within the device manager. Open this up and under the ports section, you should see that a port has been assigned to the pE-800, in this case COM5. If running previous Windows versions, there will likely be a flag next to the text, and drivers will need to be downloaded. The drivers can be downloaded from the CoolLED website at coolled.com, and under Support and Imaging Software, scroll down to CoolLED PE Driver and click Download here. Save these files to your computer, and then once downloaded, these files will need to be extracted and saved somewhere memorable. To update the driver, go back to the Device Manager, right-click on the COM port and select Update Driver. Then point your computer to where you've just downloaded the driver. Once done, we're now ready to open HCImage. If you don't have HCImage already available, then please download this and follow the instructions from Hamamatsu. Please note, for the pE-800, version 4.7 onwards of HCImage is required. When opening HCImage, a default profile is created. If you want to create a new profile, that can be done under File and Manage Profiles, or to edit your current one, click Current Profile. We'll now set up the pE-800 within the software, and this is done under IO/LED Devices, then click Add. On this screen, select CoolLED Precise Excite and go to the COM port tab. Here you can see the available COM ports, and we can see COM5 is available, and this is what we saw previously in the device manager. As there's 8 LEDs available, it's worth labeling these from the default names that are given. This is for ease of use for later on. So to do this, click on the IO/LED setup, and here you can see 8 different shutters referring to the 8 different LEDs. Shutter A refers to the UV LED, so this is either going to be your 365 or 400 nanometer LEDs, depending on if you have an SB or MB system. So I have an MB, it's 400 nanometers, so I can label that and click Shutter A. Shutter B is the second one, 435 nanometer. C is 470 nanometers. And D is 500 nanometers. The next 4 are in reverse order, so Shutter E is the highest wavelength, so 740 nanometers. F is then 635 nanometers. G 580 nanometers. And then H 550 nanometers. Once done with this, click OK, and then we're going to set up the camera. In this demo, we're going to use this as our detector, and this will also need setting up. Without a camera attached, click Image Capture Devices and click Add. As we have a single camera, I'm going to select Single Camera and click OK. And the software will recognize the camera and serial number from the one you have attached. So you can select this and again click OK. You can now see the pE-800 and the camera are both set up in the software, so we can again select OK. We're now ready to set up any settings we may want from the pE-800. To do this, go to the Devices tab and then select Add. Here we're going to name our first setting we want to set up. In this case, I just want the 400 nanometer LED, so I'll call it this and click OK. From here we can select and set up all our different individual LEDs or several at once if needed to. But to start with, we're going to set up 400 nanometer. Below, go to IO/LED device, and we can see different filters and different shutters. The shutters refers to the on-off state of the LEDs, and the filters refers to the intensity. For the 400 nanometer, this is again A, so we're going to select this, click the 3 dots, uncheck the box, and move the slider or select which intensity you require. If we scroll down, we're now going to select which LEDs we actually want on. As filter A, up here, responds to the 400 nanometer LED, we're going to select the drop down box here and check high. This makes sure that the 400 nanometer LED will be on when this is selected in an experiment. To ensure the others remain off, we're going to select low for the remainder of them. This has now set up the 400 nanometer channel. To do others, we can again click Add and set up any others we want. For example, if you want to do a 470, this is going to be filter C. So we can select that, again adjust our intensity, whatever we require, click OK. And scroll down, here we can see 470, we want on, select that to high, and again changing all the others to low. So as I mentioned, you can do this with as many as you like. So for example, if we want to do a standard DAPI FITSI TRITSI experiment, we might want a 400, 470 and 550 nanometer LED on. So the 550, recall, is going to be the one right at the bottom, so high, which is H, so we're going to change our intensity for this. Again, ensuring that all other LEDs remain off by checking low for each of them. We've now set up our DAPI FITSI TRITSI experiment. If you do want more than one LED on at once, you can set up that as well. And in this case, we want 400 nanometer LED on, 550, and the 470 for your DAPI, FITSI, TRITSI. Ensure all the others are set to low, and then we can adjust the intensities for the remainder. A for the DAPI, and then C refers to our 470. Once you've set up all these, we're now ready to run an experiment. First, go to the Capture tab. From here we can select the camera that will be used to acquire the images. Select Disk, and below you should see the camera we previously set up. Upon selection, more options are going to become available. So firstly, you can change how many images you want from the camera. In this case, we might do a mono 3 channel, as we have the DAPI FITSI TRITSI. These can be selected below in the drop-down tabs. So 400, 470, and the 550, which we set up. Here you can also adjust the exposure. If you want a live image, you can click Live and see a live image appear here, or to run the experiment, click Capture 1. The LEDs should come on in the order selected, and once completed, the images will appear. Once done, you can start processing and analyzing your images. Thank you for watching this CoolLED tutorial video.